Okay, so welcome to the first lecture on CPSC 304, Introduction to Database. My name is Hassan and I'll be your instructor for 304 this summer. Before we start, does anyone have any questions? Alright. So throughout this semester, I'm going to have learning goals for each of the chapters we're going to cover, which is going to give you some idea of what are the main things that we would like you to learn from this lecture and potentially ask you about in questions. So I'm going to have the learning goals, and then at the end of each chapter we'll revisit them, make sure that you understand all the learning goals clearly. Okay, so for the first chapter, it's going to be defining the term database and explaining the purpose of having databases, and also explaining high-level objectives of database management systems, DBMS, and explain how a DBMS relates to a database. Okay, and also talk about benefits of a DBMS. So these are the things that are going to come for the first chapter. So this is going to be a long lecture. It's 2.5 hours, and you guys don't really want to be listening to me all the time. So we've designed the class so it's going to be a lot of interactions between you and people sitting around you, which makes the class more beneficial for you guys and less boring as well. So let's start the first discussion. Suppose you're building a system to store information pertaining to university from scratch. You have access to an operating system of your choice, but that's it. You'll have keyboard, mouse, and everything, but that's it. What do you need to figure out, and what do you want your system to do and why? So if you don't know your neighbors yet, just introduce yourself and start talking about this, and we'll talk about it as a class in a few minutes.
Hi.
Thank you very much. Can I get your name as well whenever you... Anastasia. So, how to store that data, and once we've stored it, how we can query it well, right? What else?
Probably, what introduction you want to store is course lists, like student numbers, teacher or professor information.
Great. And your name, please?
Yelena.
Daniela. Okay, so what you need to store before being able to store it, first you need to think about what it is that you're interested in, And you can make a conceptual design first, and then start thinking about how you're going to store that. Great point. What else? Yeah?
You need to be able to access and change it concurrently.
You need to access and change it concurrently. With 40,000 students at UBC, you don't want to be changing or registering one at a time. So that concurrency and accessing your information is crucial. And your name, please?
Reggie.
Reggie. Yes?
Find a way to make all data quickly accessible, no matter what the function, it always gets the same time in and out, or roughly equal to.
Great. Your name?
Mike.
Mike. So there's a lot of you, but I'll try my best to learn names as well. So accessing it quickly, and you mentioned something else as well.
Well, yeah, just trying to get it all quick and all roughly the same time.
Roughly at the same time. So you want to maintain a balance in how fast you can usually access that data. Yes?
Since it's personal information, it should be secured. And you have to manage the access. Who can access and what kind of information?
Great one. So security is very important. You guys you're leaving all your information with UBC here, and you really want UBC to keep that secure. And also, different people will have different access to that data. So think about a DB admin or a registrar looking at the database from UBC. And you only can see your own file and not anyone else's, but someone else accessing that data might have more privileges and seeing other people's information as well. Anything else? Right, so here's a few of things that I sort out, and you guys had talked about most of them. So you need to figure out how do we want to store that data, what sort of organization, file organization we're going to use in order to store that. We're going to figure out how we're going to query that data. It's important that once you have a lot of data, you'll be able to access what you want quickly in there. Make sure that your updates don't mess things up. So you want to make sure that if you update something, you can only update what you're allowed to. So as a student, you shouldn't really be able to update your own grades. That would mess things up. Access requirements, provide different views on data and who has access to what. And how do we deal with crashes? How many of you have had a computer that has crashed on you? Yeah, I mean, we all really love to write software that doesn't crash, but unfortunately it's just an undeniable fact that it's going to crash at some point. And when a computer crashes, you don't really want to lose all that data that you have. It would really suck if the UBC database crashed and we lost all your grades. For some of you that might not be that bad, but generally that'd be a bad idea. Alright, so let's see what a database is. A database is an organized collection of related data, usually stored on disk. It's typically important, and important is subjective, but the person who's keeping that thinks it's important. It's usually shared between different users using that information. It's secure, so you want to keep it secure. It's well designed, so there's not a lot of redundancy in what you're storing. And it could be variable in size. You could have a database for a university and you'll be able to keep 5 students or 5 million students. And it should be able to handle both of these. A database typically is showing some real-world enterprise. Again, we can think back about UBC, where you have entities. So entities could be the students that we have, the courses that we have, instructors, all sort of information will be entities. And relationships will be how entities relate to each other. So for example, a person can take 221 and they can get 55% on it. Any questions? Okay, so given that a lot of enterprises will need such a system, with a lot of similar features, doesn't really make sense for UBC or any other enterprise out there to start writing such a software themselves. First of all, we're all lazy, it's going to be expensive, and not every enterprise has the professional people that would understand the security and integrity of everything in a database. So what we're trying to avoid is reinventing the wheel for each enterprise to come and sit down and try to write a database and manage it themselves. So the question is, we have all this data, it's very important for us to have that data in place, but who takes care of that? And a database management system, DBMS, is a bunch of software which is designed to store and manage the data that is important for us, which is inside our databases. DBMS will allow you to define, modify, and query a database. It will give you control access so you can tell who can see what at what time. It permits concurrent access. Again, it will allow multiple students, if you're talking about UBC again, to register at the same time, and you don't really have to wait for everybody else to be done before you can register for the courses that you want. Maintain integrity. That's also an important one. All of you that are here have maintained some integrity, meaning that there were some prerequisites for this course that you currently have, and that is why you were able to register for CPSC 304. And DBMS is in charge of making sure that all you guys have the right prerequisites. It should allow you to provide a backup and recovery mechanism. So we say that it's unavoidable for a system to crash, but that doesn't mean we shouldn't have a plan B in case something does crash. So we think about what it is that we need to do in case the database crashes at some point. Okay, so it seems like everything's taken care of. So what are we going to do in this course? In this course, first we're going to talk about conceptually modeling the concepts, and then logically modeling the concepts, deciding which user will ask what queries, make our design efficient, create an application, and enjoy it. We'll also talk a little about transaction processing and concurrent access, and recovery from crashes. Let's see a bit about each of these concepts that we're going to look at. Conceptual modeling is, we're going to use ER models, entity relationship diagrams, to first of all design the concept. This was something that mentioned by you guys as well. Before actually storing the data, you need to have a design of what it is that you want to store. And these pretty pictures here, we're going to get into later today, is going to give you a design that you have entities such as students, such as courses, and professors, and some of the information that you want to keep for each of those. For example, for student, you might want to store their student ID, name, and category, and along a lot of other information. For courses, you'll have some information. With professors, you have some information. And then you'll have relationships between these. So a professor might advise students, or a student might take a course, or a professor might teach a course. So we're going to start with conceptually thinking about the design, and after we'll take it from there to go to the logical modeling. Once we have that concept in place, how can we transfer that concept into a model that we can use in a database? Question?
In the previous page, why are some of the words underlined?
That's a great question. Your name?
Johnny.
Johnny? So Johnny is asking, why are some of the attributes here underlined? We're going to talk a lot about keys in maybe half an hour-ish. So we'll come back to the underlying values soon. Any other questions?
So having a database of students and knowing that can you access through student, can you access information about the professor and his name and address and fields?
So the question is, in this database, can students look up professors?
Yeah. No, for example, me, if I have all information about a student, can I access a professor? Is there a link between student and professor?
Okay, so the question is, how would students relate to professors in this model?
Yeah.
Is that right?
Yeah.
So this is again something that we need to think about when we're designing a database. For example, a student might relate to a professor based on the courses that they're taking. So if you're taking a course with a professor, you have a one-to-many relationship with that professor. If you're taking some courses, you might have some relationship with the courses that you're taking. And these are the sort of questions that you need to consider and answer before you get into actually designing the database. Does that answer your question? Okay, so once we have the model in place and we know what it is that we want to talk about, we need to take that concept and logically model it. And we're going to use relational models in order to do that. So later, once we have the concepts, we're going to design tables, and inside those tables, we're going to keep the information that goes with the model that we have in mind. For example, you can have a table for students where you keep the student name, the course that they're taking, and maybe the term that they're taking it in. And this is going to be relational models. And relational models is something that we're going to be studying in a lot of depth in this class. So I'm just giving you a review of basically most of the stuff that we're going to be doing throughout the whole semester. Once we have the tables and we have the model, we need to think about how we're going to query this information. We're mainly going to use structured query language, or SQL. And basically this could be an example of something that you write in SQL. You select some people from some table where some condition applies. Okay, so this is one way that you can do this. SQL is a declarative language, which means that you only say what you want to get. So this is me saying that this is the information I want to get. And you don't have to specify how you're going to get that. And the database management system will basically take that query and optimize it for you, so you don't have to worry about that. In this course, we're not going to look at one, not two, but three different languages. So we're going to look at SQL, we're going to look at relational algebra, and also, if time permits, we're going to look at data law. So we're going to look at all these three languages and see what are the benefits and disadvantages of each of these if you want to query some information using these languages. Any questions? Okay, so once we have a model, similar to the one that we have here, we really want to make sure that it doesn't really have much redundancy. So once we take that model, we're going to think about how we can make that design efficient. And what we're going to learn is how can we capture all that information and take less space and make it easier to maintain. Okay, so these are the sort of questions that we want to answer, and more specifically, we're going to look at different normal forms and how those normal forms are going to help us with efficient design. The course is going to have a project where you're going to make an application that is going to use databases. We're going to focus on Java and JDBC, or Web and PHP, and you're going to connect that to a database management system, and you're going to write a really cool application that shows that you totally understand how to use databases. We're going to talk more about the project soon. Transaction processing and concurrent access. How many of you have used Google Docs to collaborate between a few people? Imagine that 2 or 3 people are now thousands of people, and you're all trying to change the same file at the same time. Yeah, things can go wrong. So basically, but this is what a database would need to handle. There is one file, and potentially millions of people are trying to read, write, change stuff, update the same file at the same time. You don't want to restrict this to one at a time, because there's a million people out there who want to query this, but on the other hand, you need to have some mechanism in place that will maintain the database or the file. So you want to make sure that everybody is getting what they think they're doing done, and we're going to look at transactions for that. And recovery from crashes. Let's assume that you're currently doing multiple transactions, let's say T1 to T5, and more specifically, this T4 is a really important transaction. You're transferring a lot of money from one account to another account. And while you're doing that, in the middle here, the system crashes. What if DBMS stops running during the process? What can go wrong? Anyone want to take a guess? Mike?
I'm thinking that if you had a function where it says one account, it's depleted of $1 billion, and before the transfer is completed, it says the $1 billion should vanish entirely.
Thank you. So what might happen is that you have a function which is going to take the money out of one account, and then after it's been removed, it's going to put it in the other one. It's been taken out of your account, and boom, system goes down. And yeah, you just lost a lot of money. Or in the other way, if you first add it to the other account, and then want to remove it from this account, bank just lost a lot of money. Okay, so either way, this is not going to work out well. You need to have a mechanism which allows you to recover if you're in the middle of a transaction and you have a crash. Any questions? Okay, so here are the course learning outcomes, which is basically just putting what I was talking about into more formal sentences. I'm going to leave it on the course website for you guys to go over later. So if we're doing all of this here, then what's left for CPSC 404, and what is it that we're not going to talk about here? We're not going to talk much about data independence and efficient access in this course. Anything about the physical layer and how you actually store that data, what sort of data structures used, indexing, hash maps, all of that is going to be in 404. So data storage. Uniform data administration, having that central person that's going to go through everything, mostly in 404. Query evaluation and optimization, as I said, we're mostly going to say what it is that we want from the data with SQL. How that query is evaluated and optimized, again, it's something we do in 404. Data warehousing and online analysis processing, and also data mining. So if you really enjoyed this course, and I really hope that you do, consider taking 404, where we'll talk more about the following. Any questions? Okay, so so databases, we know what we're going to do in this course, but what is about databases that makes them interesting? Or why should you be interested in databases? Database management systems? Question? Versa.
I'm interested in them because we can improve our code and make the program work faster if we know how data gets stored and how to access it.
If we know how data is stored and accessed, we can write programs that are faster? To some extent, what we're going to see is actually one step beyond that, that if you're writing a program, you really shouldn't be worried about how data is stored. And we're going to have that abstraction that if you're writing a program, you should just query it without actually knowing how it's stored. But knowing how it's done is definitely going to help as well. Database management systems have pretty much a lot of CS covered in them. You like operating system? A lot of what a DBMS does is similar to an operating system. It's in charge of communicating with a lot of transactions and people at the same time, which is something that operating systems do with a lot of applications that they're working with. You're interested in programming and languages, we're going to look at 3 different languages in this course. You like theory? There's a lot of theory that goes on the back end of a database management system. There's a lot of mathematical theories in order to tell you how you can optimize those queries, and how is it that you can have a file which is maybe, it's a very big file, and you can still query it very quickly. So there's a lot of mathematics and theory that goes with it. If you're interested in AI, we have intelligent systems which allows you to look at data mining and see if there's anything out of the ordinary which is happening inside your database. If you like multimedia and logic, there's a lot of logic between, if you're talking about relational data, we're going to talk about a lot about logic. And multimedia, we use a lot of database in order to store videos or sounds that you might have in multimedia. So data sets are increasing in diversity and volume. We have digital libraries now, which are replacing a lot of just the normal libraries. And the amount of data that we have has been doubling every 18 months since 1990s. You can just imagine how much data we're just building off, as it's being doubled every 18 months. They're fun, they're combining everything, and everybody has data. What I want you to do for a few minutes is, again, talk to your neighbors about what sort of data do you have and why do you need to store that. Any questions? All right. Medical information, your name please. Yuyan. So medical information. What else? Name as well? Kai? So pictures and videos. Yeah, we have a lot of that. And it's hard to keep them organized. So that's maybe one thing that a database could help with. How can we store all that pictures and videos organized? Anyone else?
The material from the previous courses.
Material from previous courses. I know I'm always updating mine. Yeah, especially if you want to keep one copy and you want it to be always updated, it's always hard to keep that organized as well. What else? Yes?
Emails and text messages.
Your name, please?
Sina.
Sina. Emails and text messages. Thank God some of that is done by our Merrill clients. But I know that I'm personally always going back in my emails trying to find stuff. So having a search that works well on your email or messages is very crucial. Thank you. What else? Yes?
Folders.
Folders?
Yeah.
What sort of folders?
Like, folders inside of folders.
Oh, right. So keeping and your name, please? Michael. So if you have information which is stored in a lot of different folders, so you have a complex data structure for it, how do you keep that information organized? What else? Yes?
Locations for the things you stored?
Locations. You actually have a lot of information around. You want to know where you've stored everything. Thank you. Your name?
Cassandra.
Cassandra. Okay, so a lot of great suggestions. Here's a few things that I keep. Some of the data that I have. Books and papers that I've read. You want to keep those so if you want to reference them later, you have them in places. Addresses of people, and this could be contacts, this could be their telephone, email, address of people that you know. Job search data, whenever you want to apply for a new job, it's always handy to have your previous material somewhere safe in place. Experiments that I've run, so anywhere, whenever you want to do some study, you run some experiments, and I keep those around as well. Your grades. It's always important to have your grades around. CDs, DVDs, and books. Financial records. This is a little different to the other ones. So these are mostly I want to keep organized. This one you might want to keep secure as well. So sometimes that security is something which is really important when you're thinking about storing information. That can also go with photos as well. Does anyone have any questions? Question? Yeah.
What kind of experiments do you run?
What kind of experiments do I run? So my PhD was mostly on machine learning. And machine learning is, well, really, machines don't really learn. So what you do is you give them a lot of information, statistical information, and based on that, they'll try to keep patterns and understand something. So what I was doing is I was taking a database's inputs, one of the focuses of my PhD, and based on that database, I was trying to see patterns. So come up with some general rules, for example, that if a student has taken 221 and they've done really well, that means they're going to do really well in 304 as well. Thanks for asking that. Any other questions? All right. So the primary goal of this course is for me to help you manage data using a database management system. And you learn mostly by sitting there and going on YouTube. No, you mostly learn by doing stuff. And in this course, we're going to give you a lot of opportunities to do stuff. We're going to have in-class exercises, so make sure that you bring your clickers and pen and pencil to the lectures. We're going to have a project where that project you're going to design an enterprise application on one of the database management systems of your choice. We have MySQL, we have Oracle, we can do other ones as well. And this is going to be in groups of 4. So given that this is the summer semester, and it's very short, you really want to start thinking about this today. I have the project on the course website. I'm going to give you the URL as well. You can start by reading some information about the project and different phases that we're going to have for the project. We're going to have tutorials, and tutorials are going to be examples reflecting on what we do in the lectures. We're not going to cover anything new in the tutorials, so all the material will be covered in the lectures, However, I strongly encourage you to attend the tutorials, as they're going to give you a lot of hands-on experience about the stuff we talk about during lectures. There are 2 tutorials a week, once on Wednesdays and one on Fridays. And there are 3 different tutorials, 9 a.m., 1, and 2. And it's funny that how this 9 a.m. one is always, most people have taken that, and least people always show up to that. So there's a strong correlation between those two. Due to space limitations, I'm going to ask you to attend your own tutorial slots for now. There's 120 of you, and our tutorial has spots for 40 people. So it would start getting really messy if you want to go to the other tutorials and there's not enough room. Later in the semester, if there's enough room and if you can find someone to switch, no, forget I said that. Later I might relax that, but for now, please do attend your own tutorial. The tutorials are semi-optional. And what do I mean by that? There's 2% for participation in tutorials and working, and you hand in what you do through the tutorials, and it'll be marked based on whether you made an effort to finish the tutorial or not. So it's either a 1 or 0 based on your effort, and there's 2% for that. And if you don't show up to the tutorials, that 2% could be added to your final. Okay, so I'm going to get two different grades for you. One with the tutorial attendance and one without that. So it's going to be added to your final, and I'm going to take the better of the 2. But again, I strongly encourage you to attend the tutorials because first of all, it's going to allow you to do better in the exams. And secondly, that 2% by attendance is much easier to get than actually getting it on the final. So, word of advice. But again, I don't want to force you, especially if you already have some background with databases, and if you feel like you know the material, this is a way for you not to attend the tutorials if you're already confident with the material. Exercises. So on tutorials, before I move on, tutorials are going to be in 2 different locations. Sometimes they're going to be in classroom, because what we're going to be mostly working on some problems that you don't really need a computer. Sometimes they're going to be in X350. And what I'm going to do is, on the course website, I'm going to always tell you where is the location of the tutorial going to be held. Okay, so we're going to start on Friday, May 16th, and the first one is going to be in the classroom. The location is going to be Dempster 101. So it's just right across the hall from there. Any questions about tutorials or projects? Okay, so exercises for you to work on your own. What I'm going to do is, I'm going to have an exercise page. Here you can find sample midterms from previous semesters. And for each chapter, I'm going to give you some questions that I feel like they're pretty good for you to do. And also, the solution for all of those is available on the website as well. So, here's the manual. You can do them, and then you can check yourself to make sure that you're getting the right answer. To encourage doing the exercises, at least one question per exam will be isomorphic to a tutorial, homework, and an exercise. And by isomorphic, I mean that it's going to have similar concept, but maybe the values and the variables or the interpretation might change a little. Okay, so this is something new I'm going to do this semester. I think giving students immediate feedback on what they're doing for any of our courses at UBC is very important. And in order to do that, we need to have a lot of questions and answers for those questions. Unfortunately, it's hard for just the instructor and the TAs to come up with all those nice questions. So I'm going to ask you guys to create those questions. So we're going to crowdsource the problem. And basically, I'm going to ask you guys to come up with clicker questions, maybe similar to the ones that we have in class. And then we're going to go through those, and then I'm going to keep the best ones. And maybe for the next generation of offerings for the course, we're going to have those on the website so other people can use those and benefit from them. Okay, so if you go on the schedule page, you'll see deadlines for submission of questions. I'm going to be talking about this throughout the semester as well. But basically, you're going to be doing 4 questions in total throughout the semester. Okay, and then you're going to get marked based on how good your question is. So please try to come up with good questions. That will help the next generation of the students and your own mark as well. Any questions? Okay, so here's the planned assessment for the course. We're going to have clickers, and that's going to be participation only. So I'm not going to check whether you got the right answer or the wrong answer. Those tutorials are semi-optional. They can be moved to your final. Creating questions is going to be 2%, so that's 0.5% per each question. That's quite generous mark for a question, so make sure it's a good one. Project is 18%. We'll have the first midterm. It's going to be during lecture. And if you go on the schedule page again, you can see the dates for midterm 1 and midterm 2 on the course webpage. And then the final to be scheduled by the time is going to be scheduled by university is going to be 40%. We're also going to use Piazza for this course. And Piazza is going to be where we're going to have most of the discussions for the material with regards to the lecture, tutorials, or the project. To encourage active answering questions on Piazza, the other students can also answer to the questions that students have. This is 1% extra, so if you add all these up, this is going to be 101. That I'm going to give to selective students that are really active on Piazza. If you also enjoy being a TA at UBC, we mostly get our TAs also from those students that have concrete responses on Piazza. So if I see that as well, I can recommend you to be a TA in the department as well. To pass the course, you need to pass the final and the course. And I always say that this grading scheme is subject to change. I rarely do, but I do reserve the right. Any questions? Okay, so to enroll on Piazza, if you go on the course website again, there's a link for Piazza. Here you need to add a code, and the code is going to be CPSC 304. So please do enroll in the Piazza for the course. And my pledge to you, given that this is my first time teaching this course, if I mess up, you guys should not be screwed. Okay? So my pledge to you, this class's average will be at least as high as the average of previous CPSC 304 offerings. And if you're curious to know what that is, that's currently 71%. Okay, so the average for this class is going to be at least 71%. Any questions? Alright, so collaboration and cheating policies. In general, we want to encourage you guys to collaborate as much as possible with whoever you want before you turn in anything that we want to do in the course. As you can see, there's not really much assignments, so midterms and final, there's not much there. There's mostly the projects, and you're going to be having different projects. So you can collaborate with whoever as long as you go with the 3 rules. You must acknowledge everyone that you collaborated with. You may not take records or notes away from your collaboration. So think about it, but don't write it down so then you have the same answer. And you must spend at least an hour after collaboration doing mindless activities. That part is in order. So that means that if you come back to it after an hour, if you still remember it, that means you actually learned it and you're not actually copying someone else. My current mindless activity is watching StarCraft. Just a suggestion if you guys are interested. Okay, so exceptions are going to be on project, you can collaborate with other group members, and you can obviously collaborate with the instructor and the TAs. And, other than that, just follow the spirit of rules and use your common sense. I'm going to have readings in the course website for each of the chapters that we do. So chapter 1, reading chapter 1 and chapter 2, read chapter 3, and you are responsible for the material in the reading parts that I mentioned, even if they're not specifically covered during the lecture. It's highly unlikely that I'm going to ask you questions in the final about something that I haven't touched in the lectures, but still, you are responsible for knowing that information. Handouts, I'm not going to hand out the slides at the beginning of the lecture to you, but I'm going to have them online by 9 p.m. the day before the lecture. If I get it up way sooner, I'm going to post something at Piazza, so if you guys are interested, you can download them earlier. Alright, so let's get your clickers out, please, if you have them with you. And can you answer it only, please?
Are you about to skip the 2 or 3%?
A few more seconds. Okay, so multitasking on computer will. So at least the majority of you agree that it's going to make you learn worse and distract the people around you. And it's true. I know the lectures are long. It's going to be 2.5 hours. We're going to have a break somewhere in the middle, just to give you guys a break. But I know it's long. I know there are times that it might get boring. I know that you may feel like that you can be shopping on eBay at the same time, and yeah, you're really learning the material just as well. It's not true. So there are multiple studies that show that if you are multitasking on computer during a lecture, you're going to do much worse in the exams or throughout the whole semester. So the last study that I've seen shows that there's 11% lower average for those that are multitasking during lectures. And it's not just for yourself. People sitting around you will also be significantly distracted while you are shopping on eBay because they just feel like, man, I should get that as well. So, you're tempting other people not to listen as well. If you really feel like you need to be on eBay, YouTube, or Facebook during the lecture, I'm going to ask you guys to go and sit at the back, somewhere on your own, so you're not distracting other people. Other than that, if the TA and I are walking around and we see you guys multitasking on unrelated stuff, we might ask you to put away your laptops. Okay, so just the wording. In this class, we're going to have, other than that, these are long lectures, right? And something that I say at the beginning of the lecture is going to correlate heavily with something that I'm going to talk about later in the lecture. And unfortunately, if you miss part of that, it's always going to be hard to understand the rest of the lecture. And each lecture is a week of material in a normal semester. So you don't want to be doing that to yourself. Where to get more information? The course website is UGrad CSUBCCA CS304 2014 S1. So I'm sure if you Google it, you can find it as well. And the course website is where I'm going to have most of the information. My office hours, my office is in ICICS 241. That's my office. That's where I'm going to be holding my office hours. I'm going to have my office hour Wednesdays from 1:30 to 3:30, or if you can't make that by appointment. Also feel free to come and talk to me right after the lecture. I don't have another lecture after this, so if you have any questions, I can just come and ask me after the lecture, and I'll be more than happy to help you guys as well. TAs will also have office hours that's to be announced, but you can also just contact them if you have any questions. There's a personnel page here, and there's information about the TAs for the course, their email, and you can email them to ask for an office hour. The book we're going to use for this course is Data Management Systems. Okay, and this is the course textbook we're going to have the readings from. Any questions? Right, so learning goals for chapter 1 revisited. We defined the term database and explained the purpose of having a database. And we also talked a little high level about database management system and how they relate to a database. Any questions? Alright, then let's move to chapter 2. Okay, so we're going to cover a little of chapter 2, and then maybe we'll take a break around 11:15ish. Alright, so chapter 2 is going to be about conceptual database design, the ER model. In our last exciting episode that we just saw, we motivated databases and how great they are because they store a large amount of data and handle transactions, allow efficient querying, and many, many classic favorites. Before we can do all these, we must design a database. And this is what we're going to be mostly talking about today. Okay, so here are the learning goals for today. I've already put up lectures, notes for today as well. What I'm going to do is I'm going to have pre-notes before lecture. I'm going to have those up. And then after each lecture, I'm going to add slides with lecture notes and clicker questions. So the ones that you're going to see first are not going to have clicker questions and explanation of some of the questions we're going to discuss during the lecture. Afterwards, after the lecture, I'll add the clicker questions and some extra material as well. Okay, so these are the learning goals. Make sure that you go and read them. There are 3 levels of abstraction when we're talking about a database management system. Okay, so DB system, we're going to have 3 abstract levels. One is a physical level, which is here at the bottom. And this is all about how is the data actually stored. How can we store all that information that we can easily access it whenever we need it. And again, this part, we're not going to do much in this course. If you're interested, CPSC 404. Conceptual level is basically interacting with that physical information. Once I have that information on file somewhere, how can I query it? How can I make changes to it? How can I get aggregate information from that? Any sort of conceptual level of how you design it and how you query that data is going to be in the conceptual level. And 304 is mostly going to be discussing the conceptual level that we have here. The external or the view level is going to describe how different users may be interacting with this data. Okay, so again, if we go back to our UBC example, this view could be how a student is seeing this, the view 2 is how I'm seeing it as an instructor, and view 3 is how a registrar will see it. And we're all interacting with the same data. It's not that I, as an instructor, have a different database that I'm interacting with compared to the one that you're using as a student, but rather, it's just that the way we view this data is going to be different. One set of data only. Why is it a bad idea to replicate that data and for me to have a different data to the one that you're accessing? Yes?
If changes are made, then they won't be reflected in the copy.
Thank you. Your name, please?
Meganka.
Nagana?
Meganka.
Rakanka.
Yeah.
Thank you. So, it's hard to keep everything. So let's say you change your address, or you change something about your student ID, something. It's hard to keep that maintained if we have multiple set of those informations. So we're going to try really hard to just have one set of data, and we all want to be using that same data. We're going to design a schema, which is the logical structure of a database. So a schema is going to talk about students, courses, instructors, as a template. So this is going to be a conceptual or logical schema. Later, we're going to populate instances that go with this concept. So once we have the concept in place, we'll start enrolling students in. We'll start hiring instructors in. And that instantiation of that schema is then going to be having actual values inside that database. So the schema will be talking about general students and courses. The instance will say that there are currently no grades for CPSC 304 for the summer semester. Or that a student took a course and they got 85. In our ER model, we're going to have entities which are usually nouns. But we'll try to avoid irrelevant nouns, obviously. So students or courses are going to be entities in the model that we have. And relationships are statements about two or more entities, which often tend to be words. So a prof teaches a course. And that teaching, which is relating a student and a course, a prof and a course, is going to be a relationship. While we're doing the conceptual design, what we're thinking about is what information about these entities and relationships should we store in a database. So we're thinking about all the information that we need to keep, and we're also thinking about the integrity constraints or the rules that we need to have in place. Again, so if you guys are taking this course, you needed to have some prereqs in place, and these are the sort of things that we want to consider when we're designing a database. And this is called the entity relationship, or ER in short, diagram that we're going to be discussing for the rest of today and sometime on Wednesday as well. Okay, so here's the first pretty picture we're going to look at. Many to come. Ta-da! This is an entity. So an entity is a real-world object that's distinguishable from other objects that we have. And for a very, very long time, we had an example which was on UBC. And after that, we had another example which was on managers and employees. And we thought both were boring. So recently, we've moved to movies and movie people. So I apologize if there are small things out of place with that. Hopefully they're not. I've checked it a few times. But we've tried to come up with a more exciting example now, which are movie people and movies. Okay, so here the entity is movie people. And for movie people, we're going to keep their ID, their name, and maybe their birthdays. An entity is described using a set of attributes. Attributes are ID, name, and birthday here. And an entity set is a collection of similar entities, e.g. all of the movie people. So an entity set will be the set of all people that are movie people. All entities in an entity set have the same set of attributes. So any movie people that I want to keep in this database are going to have the same set of attributes. I'm keeping the same information for all of the people that I have. There's going to be a domain for each of the attributes. ID could be a number, name could be a string, and birthday could be a date that I'm storing. And each entity has a key. And this is coming back to the question that you had before, is why do I have this underlined here? Let's ask you guys, so why is it important that you, as a UBC student, have a UBC ID? What does that ID allow me to do as an instructor, or for you to do?
Unique identifier.
I need an identifier. Why would I need an identifier?
Because the names might be similar.
The names might be similar. Your name?
Yu
Yang, I forgot, sorry. So Yu Yang says that we need to identify people, and he's right. Because if I want to add your grade for CPSC 304, I need to be able to uniquely identify you to then assign that value to you. It will not be very useful if your student ID are similar to each other. So if I have 5 people with the same student ID, that student ID isn't really helping me in identifying who you are. So in the database, in order for us to be able to update that or insert new values into it, we need to be able to identify uniquely any object in that database. To uniquely identify them, we need to have a key. So a key is going to distinguish different entities that we have, and a key is going to be the minimal set of one or more attributes which taken collectively will identify you uniquely. If I knew that if I take your first name, your surname, and your date of birth as a UBC student, that would be unique, then I didn't really need a UBC ID for you guys. Unfortunately, that can't really be true. Or at least there's no way for me to prove that that's true. Especially if your surname is Lee or Chan, chances are that's very unlikely. So a key is going to be a minimal set. Let's take an address for an example. For an address to be unique, if you take the street, the house number, and the postal code, I can uniquely find any address that I want. So based on these three, I can infer what the city is, and I can infer what the province is. And it's minimal because I can't really take one of these out and still have the key. For example, if I take out the postal code, then just having street and house number by itself is not good enough for me to uniquely identify all of my addresses. Any questions? Yes?
So for the diagram on the first slide, the key for the professors is name, but then there might be duplicate names.
Let's see. So, the question here is it really a good idea to have name of a professor as their key? And the answer is no. So nobody says this is a good design. But you're right, now you think it clearly. Would a professor name be really unique enough for them to be identified? So the key here is name, and it's a really terrible key. Thank you for spotting that. Any other questions?
Would you consider each of the underlined points the primary key in itself, or there is only a primary key when it's a collection?
Thank you. Your name?
Sammy.
Sammy. So the question is, since I have underlined three different attributes here, is it the fact that I have three different primary keys, or is it that the combination of three is my primary key? And the answer is that the combination of the three will give you your primary key. There's always only one key per table. So you can't have multiple primary keys for one table. We're going to talk about this more later. What if there are multiple things which are unique in an entity, but only one of them could be the primary key, and the primary key is usually taken by the principal DBA. So whoever is designing the database. Any other questions? Okay, so later we're going to talk about super keys, and when we're talking about normal forms, but for now, let's not worry about that. We'll get back to super keys later. Okay, so we looked at movie people. We can also have an entity movies, where I'm storing the ID of that movie and also its title. Again, with a movie, you can have multiple movies having the same title, so that title is not really good enough to be the key. That's why I'm adding an ID here. And you can have a relationship works on, which is going to say that these movie people have worked on this movie. And they could also have a role. So for example, in this table of our database, we can have George Clooney worked on Gravity. Okay, so this tuple would be inside this table if we have movie people work on in movies. Any questions? Yes?
Can one entity has a relation with itself?
2 slides from now we'll talk about that. Good question though. So the question was, can an entity have a relationship with itself? And in the weird world of ER, someone can have a relationship with himself. Any other ones? Okay, so similarly to an entity set, a relationship set is going to be a collection of similar relationships. So for example, for this example, it's going to be a collection of all movie people that have worked on all of the movies that we have, which is going to be one big table with all that information. It's actually on the same slide. The same entity could be in relationship with itself. So if you have movie people, you can have a relationship is parent of, and that movie people is in relationship with itself, and you can have two people, one being the parent and one being the child, that are in this relationship. Okay, so I have one entity, a relationship, and the same entity is happening multiple times in this relationship, but there are different roles. So one role could be the child, and the other could be parent. First I had this as is spouse of, but then it was hard to come up with values. So I had wife and husband, and that wasn't really working, and then so I just changed it to is parent of.
So in a hypothetical database, would you have it that movie people contains like a little array of movies that they worked on, or how would that work?
So the question is, how would we store those movies? Is that the correct, or is that the right answer?
Well, how do you associate movie people with the proper movies? Is it that a certain movie person would have a big list of movies they worked on in their entity, or how's that?
Right. So the question is, how can we store the movies in movie people and then make those associations between them? And the short answer is, we're not going to worry about this in 304. The longer answer is that you can have a table for just movies, and you can have another one for movie people. And then if you store the key of one in the other, you can make those associations between them. So let's say movie has ID 5, and then I can say movie people 2 has worked in movie 5. And I need to store that value on the other
So
side.
simply we can treat those numbers ID as pointers, right?
Exactly. So, but this is just conceptually, right? We're not going to talk about how this is stored on disk. But conceptually, I'm going to have a table work on where that table work on is going to keep track of the ID of both sides, so I can make that association. A relationship may also have descriptive attributes itself. So this worked on here that I have can have descriptive attributes itself, like role. So I can keep the role of each movie people in that movie. Any questions? And it's possible to have more than two entities, multiple entities, having one relationship between them. And this is just a mathematical way of saying that you can have entities E1 to En where all of those are going to be in the same relationship. Okay, so let's take a 10 minutes break. It's 10 past, let's resume at 11:20.
I need to take them like like this one.